I'm looking at question 9 from exercise 3C. I'll show you the question in the book. Function a times t times e to the power of bt squared has a maximum value of 1 when t equals 2. Find a and b. So I've translated that information. Has a maximum value of 1 when t equals 2. You can see the way I've written that as there's a local max at t equals 2, f of t equals 1. This is a stationary point, so we'd know that, we also know that the derivative when the t equals 2 must equal to 0. Okay, but we should plug in or substitute in t equals 2 and f of t equals 1 into the function. I always like to exhaust the usefulness of all the information given, and then I do the derivative. So I could say therefore 1 has to equal a times 2 times e to the power of b times 2 squared. I think I'll just write 4. 2 squared is 4. We might divide both sides by 2. So we could say 1/2 equals a to the power, a times e to the power of 4b. Now I suppose I could divide both sides by a, but maybe I'll just leave that for now and come back to it if I need it. I probably will need it at some point. Okay, now the derivative is a product. So we'd be using the product rule. If y equals u times v, dy dx is derivative of function u times function v plus function u times derivative of function v. Okay. So the derivative is as follows. It would be derivative of this function here, a, times function v, bt squared, plus function u, at, times the derivative of function v, so that's itself, that's the outside, the inside is 2bt, so times 2bt. Right. Always a good idea to factorize a derivative if you're going to use it. So this derivative is, in its factorized form, a e to the power of bt squared. Now there's a common factor in that term and also in this term. Right, first term, if I factorize, I'm just left with 1. And we'll have to be careful and see what's left over here. So we've taken out the a and we've taken out the e term, so we're just left with a t. Got another t there. So what if I write 2bt squared? Okay. Now I know a couple of things. I know that this derivative will equal 0 at or when t is 2. They told me that at the start of the question. And I also know this derivative will equal 0 when this bit in brackets equals 0. Okay, I can ignore this because it doesn't matter what t I use. If it's a power, I can't make this term here equal to 0. If that power is 0, then this little piece will equal 1. If that power is negative, and so on. So I can focus just in here. I could say when 1 plus 2b t squared equals 0. Right? So then we could say, we'll go up here, I think. Therefore, 1 plus 2 times b times, now t squared, I'm going to put the t in is 4. 4 equals 0. Let's subtract 1 from both sides, and let's do the 2 times 8. So 8b will have to equal minus 1, and b will have to equal minus 1 divide 8, or 1/8, minus 1/8. Okay, now that we've found b, might go back to this equation over here, unless I can see something easier. Nope. So I'll make a mark, and I'll say, using equation 1, when I say making a mark, I mean, you could put a little star there, or just some kind of label. Give it a label. I usually number. So my equations, speed size. Oh, I don't know what that does. Okay. Back to the question. Using equation 1, I could say that 1 on 2a is e to the power of 4b. Right? Or I could say that a equals 1 on 2 e to the power of 4b. Right? So I'm just doing a bit of rearranging to get an a equals, right? Because that's what I needed. And I'm just checking that I did that right. So I divided both sides by a. Yep. And then then I times both sides by I should have, that was silly. I didn't need to do that in 2 steps. Oh well, it didn't matter. I could have just divided both sides by 4b, 4 to the power of e to the power of 4b in 1 step and got this. So I could have gone straight to e to the power of 4b equals a. Well, I didn't need 2 steps. I'm not sure why I made extra work for myself there. Anyway, it doesn't matter. We're now going to substitute b is minus 1/8 and see where that goes. Right. So therefore, a would equal 1 on 2 e. Now let's think, what's 4 times 1/8? 4 times 1/8 is a half, and I've got my negative as well, so the power there is minus 1/2, right? Now I should work down, yeah, we'll start a new line. Go up here. Right, so we'll say a is square root of e on 2. It's always a good idea to work down the page, but I'm a bit cramped for space here. Anyway, so that's solved. I could check that. I could take these values back into this function. Right? So I now know that the a value is square root e on 2 times t times e. I know the b value is minus 1/8. So what if we wrote, we'll just write like that, minus 1/8 t squared. So therefore, if I put in t equals 2 into this function, I should get the answer of 1. Right? And we could do that and check. We'd have 2 there and there, and they would cancel out, so we'd be left with square root e times e. This would be minus 1/8 times 4, so we'd end up with, if we did this, why not? We'd have square root e. All right, I'm going to cancel that. I substitute t equals 2 and let's just cancel it from the start. Times e to the power of minus 1/2. All right, so if I substitute a 2 into here, that will be 2 squared is 4. That'll be 4 times minus 1/8 is minus 1/2, right? So we've got square root e times 1 on square root e. Cancel, cancel equals 1. Yep, tick. Right, it worked, and by doing that, I'm now certain that I've got the right answer, which might be worth doing because you're not always going to get nice, easy numbers like b equals 2 or 1. Here we got b equals minus 1/8, maybe thinking, is that really correct? But we can check and make sure it is. Okay.